Good morning, good afternoon, good evening, and thank you for joining this last episode of the year last live episode of the year. I need to add
Thank, thank you
of
for inviting.
Discover AuraDB was the initial plan, but we decided to do a special with Pierre Haftermeyer, who did an advent of code already last year, and he's doing it again this year. And if you follow it on Twitter, you can see what he's doing. And today he will show us a little bit. Michael is out sick, but maybe he's on the chat. Let's see. So we are down one initial person for this one, but I'm hoping it will be a fun one. As ever, if you have any questions, anything, any feedback in chat, please don't hesitate to type it in. Before we dive in right away, Pierre, maybe you want to give a few words about who you are, what you do. I don't know how sad you are from yesterday. I don't know. Maybe so people know who you are.
Okay. Thank you, Alex. I'm Pierre Altermeyer. I'm a pre-sales engineer here at Neo4j. I'm a graph theorist, doctor in computer science, and I like to play with programming languages. I love to code, and I'm a power lifter too.
Oh yeah, we can see that in the back of your room, I think. Cool.
Yes.
Yeah, that's cool. So maybe I'll post a link in chat as well. So Advent of Code is I don't know how long it's been in existing, but for a while now it's maybe you say you can explain it better than I can.
Yes.
So maybe you.
So it's a yearly event in December each year since 2015. The 25 first days of December, each day you have a programming puzzle in two steps, part one, part two, and you get stars when you win, when you find the solution of the puzzle. So it's 50 stars a year. At the beginning of the month, it's quite easy, and it's getting harder and harder each day. So yes, it's cool. There are leaderboards of people that do it with golfing languages in a few minutes, and there are a lot of students of computer scientists or people who love to code as a hobby, trying to find the solution of some puzzles or on every puzzle. And my goal is to do it in Cypher only, with APOC and GDS, and nothing more. So it's quite a good goal for me, and it's fun. Yeah.
Is it? I mean, it must be more challenging to do it with Cypher than with, let's say, Java, because it's a little bit more, limited. I'd say. I mean, it's a database query language, not a programming language per se, I guess.
Yes. Main languages used are Python, Rust, or Go, or Java, those kind of generalist languages that are procedural. You can use them as functional, anything. I said the Cypher has no INSEE limitation. You can do anything, but it's harder to use functions. It's harder to do modular code and to orchestrate everything in your code. If you have many transactions to do, it may be complicated, because you may have too much operations in memory if you don't do correctly, if you don't cut the workload into transactions. So you have a lot of APOC periodic commit or iterate, and Apoc Cypher run many, those kind of stuff that help you to orchestrate. So it's let's say, yes, it's more difficult to do it in Cypher, of course, but Cypher sometimes is a great tool, and in some puzzle, I say I wouldn't change Cypher for anything.
Yeah.
So,
I can imagine. I know we go about a couple of challenges later today, I think, but I remember when we did this last year, there were a couple of particularly graphy questions where I said, okay, we found out, okay, if you do this with Cypher, it's a couple of lines and very easy because it's I don't know, was a shortest path or something, let's say, where you always say, okay, yeah, well, find the shortest path between these 2 points, and the graph does the work for you, so you don't have to do anything. In any other language, this would have been much more difficult. So I guess it evens out in the end.
Yeah, it has its points and its shortcuts, so it's fine sometimes.
Yeah.
Sometimes it's hard. Sometimes I sweat with Cypher.
I can imagine. Yeah. Did you? Well, what's the topic of this year? I think last year there was also a topic. Is there a topic again, a theme?
Yes, of course. This year, like every year, the Santa needs to feed his reindeers, and reindeers are some particular kind of reindeers because they have some power, some superpowers, and they need to eat star fruit, a lot of star fruits. So I go with the elves in the grove to find star fruit, but in some, I say on the 5th day or 8th day, I got lost, and I have to go back to the elves to help them. But there is a lot of adventures, and yeah, I'm lost in the grove, basically.
Okay.
But I have a backpack with some useful stuff like robots, to build robots. I have some communicating device. I have to fix them in some way, but I'm an equipped guy with Cypher and my backpack. I'm good.
Okay. Sounds good. Sounds good. Sounds fun.
If one day you are lost in the grove, I hope you have some Cypher solid skills.
Yes. Would be good. And some robots, I guess, in your backpack as well. Yeah, that should be helpful. So in Advent of Code, so you did people were able to follow you on Twitter. You posted the challenges every day, I think, and
Yes.
and other people did so as well. So you can, if you're interested in doing it, you can see how Pierre did it in the past. But we will show up a few of the solutions for some of the challenges, I guess, today. I was wondering,
you can see my Twitter handle on the screen, and from the Twitter handle you can find it's only one thread of communications, and you have my GitHub to link for every day.
Cool. Yeah. So if anybody in chat is also participating in Advent of Code and would like to see how Pierre did it, you can go there. But obviously you can also watch the episode with us together. I was wondering if anybody is participating in Advent of Code in chat right now. Let us know. So it would be cool to see how did you find it? How was your experience so far? And which language did you use? Obviously, so that's always interesting. So.
Yes.
Yeah, Pierre, is this year more difficult than last year, or is it easier or same?
I'd say I don't know. There are very hard days both last year and this year. This year, the main difficulty I'd say is when we are. It's like a test-driven approach. We have always a test set test data set and an input data set to solve. And a lot of times this year, when you have a solution for the testing data set, it won't generalize because of the quantity of data you're generating, of the length, the complexity of the process. You have to be very focused on efficiency this year and on finding a linear or almost linear algorithm, because it won't generalize to a quadratic solution or to an exponential solution. So efficiency, algorithms, efficient algorithms is the key point this year. And last year, too, but not that much. That last year was more about finding like a smart solution to a problem, and this year is a smart and efficient solution. But maybe it's very difficult in this focus.
Yeah, I see. Okay, yeah, that's interesting. So you said there are leaderboards, and there is like stars for the solutions. How is, I mean, how do you how I mean, I guess if it's within the same language, you said Python. So if let's say Python, if one uses less lines of codes where somebody else, and I could guess, okay, this is probably more advanced or better written, more streamlined, and executes a little bit better. But how do you compare Python with somebody? I mean, how would you compare Cypher with Python, or how would you compare Python with Rust or Go or whatever else there is? So it must be very hard to, or is there individual leaderboards for each language?
It's a good question. It's not exactly a golfing contest. It's not about the shorter solution. It's about to have a solution the sooner. So so there are two parts. The first who find the solution for the first part receive 100 points. The second one 99, etc. until the 100th. Yeah. And the same for the second part. So you don't compare some language to another, but you have to choose the best language for the day. So the best of the best have their tool sharpened for this kind of event.
Oh yeah.
They have a lot. Have created their framework to auto submit their solution to get the input, and they have also built languages for this. Some are some are using GPT-3 to parallelizing GPT-3 to find their solution. On the first days, it was possible to do that. No, it's not possible anymore. But it will be soon. So robots are entering.
It would
in
be
the
cheating,
game.
I think.
I wouldn't say so. If robots are better programmer than me, I want to know that, and it's and let them enter the game. I'm ready. I'm with my backpack and Cypher in the Grove. No, so very interesting. The best of the best in the leaderboards can do in 10 minutes what normal people do in one day. It's impressive. Wow. How good they are. It's like they are yesterday was the World Cup final in soccer. So they are Messi, they are Ronaldo, they are Mbappe. They are really, really good, and I'm impressed. Some of them are streaming what they do on Twitch or anything. So if you want to find out how good can be a programmer, it's very interesting. So this is the main leaderboard. the best one. His name is like Peter Veros. It's very good. He's a very good one. But you can do your private leaderboard. Anyone can build a leaderboard and share it to a lot of people. So you can be on the leaderboard of many people if you want. We have one internal leaderboard at Neo4j. A lot of are using Rust. Some are using Python, I guess. So there is one, and it's the same system of scoring, but internally.
Okay. Yeah.
Internally, yes. And it's fun. It's fun to chat and say, well, I did that, and to share their impressions. Their feeling. It's very fun.
That sounds good.
Yeah, some people are using it for job interviews. Some.
I mean, if you want to know how good somebody is, I guess that's a good challenge as any. And these are very artificial challenges. Are sometimes a little could feel a little bit stupid, and then rather do something like this where it's a more of a fun way of confirming that you know what you say you can.
Definitely.
Okay, cool. Shall we show a few challenges and shall we show the people how you solve them using Cypher?
Yes, I will show you some stuff. Sorry, I will share my screen if I can.
Yeah. Should be able to.
Yes.
Yeah. Here it is.
Yes. So this is my Twitter. This is the Advent of Code page. So you have a calendar of event. Every day is an event. I have some stars to get from last days. I had no time this weekend because of a sport event. So you can choose a day, and you have the challenge with the test data, and on the bottom of it, sorry for scrolling, it's not you have you can get your full puzzle input here. For instance, I have it, and I can use it. So it's the way it works, and then you can you put your answer in this page to get the points or to test your solution. So the first day was some warm up. I can show you the solution of it. To say it was some very short lines of Cypher, get the entry, and it's like sharpening my tools, like getting used to parse some CSV data or CSV-like data. And this was like grouping and ordering. So not a big deal, but it's nice to warm up the first day. The second day was some paper, scissors, rock game with elves. And they have a very strange strategy because they want to win, but they don't want to win too much because they don't want other elves to know they have a strategy. So the input is the number of time you have to win or not to win. So I had to modelize it as a graph with it's like a state machine. So when you are in some state and you want to lose, you have to do this move and everything. So it was fun to do the modelization, and then it was easy to query. So the most interesting part was building the graph. It was very easy to do. So I built a graph, and then it was easy to query. So let's say first graphy approach was on the day 2. Then day 3.
That's a quick one, I think. I mean,
yes.
when we I mean we at Neo4j, obviously we keep saying that the graphs are powerful and graphs are everywhere, and we see them all the time, and we know we say every, lots of challenges can be helped with graphs, and lots of challenges and lots of questions are easier answered and easier taken in consideration using graph technology. But well, there's always we can say so much, and then we see it in the real world. But this is a great example. As a advent of code has nothing to do with graphs. It's a generic
Yes.
generic challenge. But already on the second one, you can see, okay, with a graph, it is. I don't know if it's easier technically, but at least it's a graphy challenge already. So that shows, I think, how deep it is interweaved in life now.
Exactly, and it must depend on the person. But for me, it's easier to build this kind of graph than to have a lot of switch, case, if, then, else, for loops. For me, it's like a control structure, but made with graphs. And with this control structure, it's part of my code. It's like graph as code, or code as graph, better said. So you can build your control structure with graphs and do some very fun stuffs.
Yeah.
Day 3, day 4 were like warm up too. The day 5 was fun. You had to stack some boxes on stacks, and you have a crane to take some and move them to other.
Okay.
And you had a lot of event that was take 3 on this one, move them. The first part was one after one, and the second one, when you take it the 3 as a pile and move them. So it changed the order. So it was very fun to build a machine with graphs. So your memory is a set of nodes and links between nodes. You have in blue here, you have like a chain of events. You have to eat events one at a time, and each event triggers some work with the crane. I can show you the code of it. It was day 5. You had to parse the data, and then it was an epoch periodic commit when you was looking for steps, and then you are rebranching your boxes on the with the crane on the stacks.
Yeah. Okay. Yeah. How did you? I mean, yeah, by a periodic commit, I guess you executed one after the other. That was like when you said, okay, there's like four moves of the crane. It's that it moves 1 box and 3 boxes and another 2 boxes or something. Then you do it via this to iterate over the various order how to say requirements or requests or commands. Yeah. Okay.
Yes, an epoch periodic commit is really good to do something while there is some things left to do. So if you have a current node or processed nodes, you are growing the set of processed nodes until there is not unprocessed anymore. And it's also good to grow anything on your graph in any direction at a time. And it's like a for loop, but on many axes at a time, and it works very, very good. This one, the 6th one, was like a sliding window on an array. It was very easy to do with pattern matching in Cypher. So this is my 14 window, 14 right window with 13 relationship, and it was very easy. So some warm up too. This one was really nice. It was like you had a shell session on your computer, and you had to find out the structure on your file system, and to compute the size on the directories on your file system. I will show you more in deep dive this one because it was fun.
Yeah.
So the input of it was a shell session, like I do a cd root ls. I can see my directory, my files with their size, and I can do cd ... to go up one directory or anything. So this is my entry. So I have this like
this was the one that was provided for the challenge.
Yes, this is the testing entry, but I can get the puzzle entry that was the same but larger. And
okay, yeah. Well, okay, yeah, I see. Yeah,
but it was a linear process of it, so it was not a big deal. Well, the last answer is 13 million, but it's not. It was not big of a deal. Not so big of a deal. So I have this entry, and I want to build my to build a tree of my directories. So what I have to do is some Cypher code. Let's say here. So I have my code. What I do, I will build some directory and files, and I need some constraint on their name and path, because sometimes they have two different directories or files that have the same name, and I don't want I want my tree to be a tree. I have no alias or symbolic links, so I only want a tree. So my path is a key to build it. First, I will build my root. My root is a directory. It's the current directory, and its root directory. Its name is slash, and its path is /2. Important to have a root. And then I will parse my CSV file, my file, the one we can see both if I do that. So I have some cd root ls dir. So sometimes this has some importance. If I see a cd root, I will create an event. I will call it will be a node called with a label terminal line. It's a line I can read on my terminal, on my shell, and I will put code in this in this node as an attribute. So I will, when I read cd slash, I put this code. So I match the current dir and the root dir, and I remove the current label on the current, and I set current label on root. So my new current label, current dir is the root dir. Very straightforward code. So for now, I don't execute the code because I'm not reading the lines of the CSV in the right order to do so. It's too complicated to do some switch case. I prefer to read all the nodes and building the code for every time I see cd root and then cd ... and then I will order these lines and build my script. Second one is when I read in the data cd ... So I put my new current directory is the parent directory of my current directory. When I have cd name, I try to find a directory called name that is the child of the current directory, and I set it as a new current directory. When I see a dir name, I'm going to create the directory, or to merge it if it has already been created below my current directory, and so I can merge a new link between my current and my new. When I have a line beginning with numbers, it's a file, and I will create a file node with name and file size and path.
Okay.
Also. Yes. So it's the way I pass, and then I chain this, ordering them by the number of the line. So I can execute this in some Aura instance. Am I connected? Okay, you are connected. Perfect. Well, I can. Now I have a list of events, and I have a root dir. So this is the list. This is my script as a chain list of terminal line I can see, and they have code. So I can execute it as a script to build my to build my tree. My tree. So I will concatenate them, and with apoc Cypher run many, I can run the whole script here. Yep. And this is built right now. So right now I have my root dir.
Now it's connected. I see.
No, I don't know if it's the root dir, but it's.
It was the root beer before. I don't know. Well, it's not
this
anymore.
Is the
probably
current.
Current. Yes. Yeah. Not anymore.
Root
the root
is the
one.
red one. No.
Yeah.
And I can. Do I have files? Files are the leaves of it. So I have my root dir, my current dir, and my leaves here built with this script. So, and now
it's very clever.
Yeah, and the next thing I had to do was to compute the size of them. So I know the size of the files, but I don't know the size of the directory. So if I have a directory with only files in it, I can sum the size of the files, and it's the size of my directory. And then recursively, when I know the size of each child of some directory, I can compute it. So I match all directory that contains child where none of them has no size. Or I could say where with all of them are half size, is the same thing. And then I compute it as I compute the sum, and I set the sum as the size of the new one. And I do it recursively with apoc periodic, and it will compute the size of everything. So apoc periodic. I love apoc periodic. So in 4 batches, it has the size of everything. So this one has a size 94853, and root dir at the biggest one, 48 megabytes. And then I add I can answer the problem, find the smallest directories that, if deleted, would free up enough space on the file system to update. Okay, no, this is not the first question. This is the second one, sorry. Find all of the directory with a total size of at most 100,000. what is the sum of the total size of those directory. So it's very easy to answer. This is the sum of the size of directory resize under this threshold, and I can answer it very straightforward here. And it's my part one solution, 95,000. And as is the test data, I can ensure my algorithm works, and I can.
Okay, yes, I see. Yeah.
Yes, and part two was some other calculation on the same tree that was not. It was finding the smallest directory. So it's not this one. The smallest directory with size above some threshold, and this was this code. So, okay. So it was nice to build this tree to pass the data. This is
So you basically emulated a file system within Cypher, or well, not emulated probably, but kind of mimic, at least I would say.
Yes. Yeah. It was nice. This is a visualization I did with NeoDash. It's a Sunburst, and it's a visualization of my file system. The black center of it is the root, and then its child directories are those one. There is a big one here. It has a child and recursively child, and the leaves of my Sunburst are files with their size. So this is not on the testing data; it's on the input data.
Okay.
It was fun to do, and very easy to do that with NeoDash. It's only 4 lines of code. So I love APOC periodic, but I also love NeoDash.
NeoDash is great. Yes, it's really good. So
it's so easy to do some great stuff and beautiful and everything. I love it. Day 8 was like finding the perfect place the perfect spot for my tree house in the grove, because we have to camp on trees, and we have to maximize our visibility. So it was on a grid. Every tree has X and Y coordinates. And it was with a grid graph you can do things very easy. There is a lot of grid graph in Advent of Code every year.
Okay.
2D grid graph and 3D grid graphs. The ninth day was fun. You are on a rope bridge, and there is something that goes bad, and the bridge is collapsing, and there are some ropes everywhere that are moving and trying to hit you with their knots. So it's at the end of it, it's like a snake, the snake game you had on your phone.
Oh yes.
So you have to modelize the movement of the ropes like a snake. It's like at the beginning is a 2 knots rope, and the second one is following the first one, and then it's a 10 knots rope, and so it's getting harder. And I modelized it with graphs and not only a grid. So I put this nice meme everywhere, and it was fun to do. The more difficult stuff is like always when it's a big problem with a lot of data and a lot of rules. It's like orchestration with APOC periodic commit and with APOC run many with call. So if you have time to read the code, it may be interesting. This one, no, I can. I didn't want to spoil, so I put another. I flagged it, but you had a CRT screen, like a cathode ray tube, the old one. So you have like a ray of electrons, like are doing this. And you have to synchronize like a filter to with this ray, with this electron ray, to write something on your screen, and you had to decode some assembly code. It's D10. I will show you. You had some assembly code of what you do. You have a register, and you can add to the register some value, and you can do nothing. And so it was a very simple assembly code. You had to parse and to decode the message you were receiving on the screen. So my message was like buckcake bows. I don't know how to read that, but it was the solution of the problem.
Okay.
It's so those who have no auto commit, those who have implemented an auto commit on their framework to solve advent of code need an OCR, but I didn't do that, so I read by myself, and I wrote it on I wrote the solution.
Okay.
Day 11 was a graphic problem. You had some monkeys that had stolen your backpack, and they were they were watching your stuff and throwing them to other monkeys, and their action was function of your wariness about the stuffs. So it was you had some fun calculation of wariness when they were watching, when they were storing. So so you had to compute on a graph moving tokens on your graph, and with computing the wariness, and there was some modulo operation of it. I say that it may not be important, but in the part 2, the size of the problem was huge, and it was not possible to compute any movement on your graph, to compute any round of objects throwing. So you had to find some cycle on your data with like modulos and arithmetic operations. So it was some math to some math background could help. So this was an epoch periodic commit, like many times on the graph I had built. And then the part 2, is this the part 2? Yes. You could where is that? Yes, I can use the product of some data, because it's the LCM of the data, because they are prime between each other. So it was fun to reduce the size of the problem, observing there was some cycle, and it happens a lot in advent of code on second part. The day 12 was fun. It was you had a height map on a 2-dimensional grid, and you had to find a way from your start from the top of the mountain, and you couldn't go from one cell to the next one if there was more than one step of height between.
I see.
Yes. So you
have to only one point at a time.
Yes.
Okay.
But if you wanted to go 20 step lower, it was not a problem. So I suppose you
Yeah.
had some parachute or
Yeah.
something.
It's like you say, they all come down eventually, but well,
But it was fun.
might be hurting.
Yeah. So this is the testing data. So a grid graph, and I have a path here to go from the beginning to the end. I computed it with a shortest path with GDS. I used
Yeah.
Dijkstra algorithm, and it was very easy to do with Dijkstra. What's fun with Neo4j and GDS is that you have a Python client, Python connector between.
Yes.
So it was not cheating. I used Python, but after solving the problem, it's important for me to say that. So because I wanted a nice visualization of it, so I did this with Python and GDS with Matplotlib. So this is on the final on the input data, the pathfinding of it. So it was fun to do this GIF.
Yeah, that's cool. I mean that. Yeah, I think
yes.
it's good if you see what's happening. So that's another obviously adds gives you feedback and helps you a little bit more to see what's going on. So
yes, and it was fun to do. First time in my life, I built a GIF. GIF or GIF, I don't know. It's a long life debate. Day 13 was very interesting. So it may be difficult to explain, but you had to compare numbers, but they are not normal numbers. They are numbers built with lists of integer and lists of integers. So for instance, these are two numbers, and you have to find which one is the greatest. So the greatest here is the second one, because it's like you have to use a lexicographic order. So you can't. It's a tie, 1-1. It's a tie, 1-1. It's also a tie, and 3-5. 5 is bigger. So the second one is the biggest one. So it's easy when there are a list of integers, but sometimes the length is different. So to tie break, the one if you have a tie, the one with data left is the greatest. And when you have a list versus an integer, you have to convert the integer into a list of 1. So and it can be recursively very complicated, because you can have nested a lot of nested level of recursion.
Okay. Yeah.
So to compare two nodes, I had to build like a graph of pairs of them. So I have a pair linked to two nodes, and I build only what I need to compute, because it would be too big of a graph if I computed everything. So
Yeah.
for every pair I have on the left and on the right what I want to compare, and I chain a comparison I have to do to compare them. And when I have my comparison tree built, I use epoch periodic to say, here I have a solution. It's the first one is greatest, so I can go upwards till my root comparison to say I have broken the tie between in my comparison. And there was a lot of things to compare. And the second part of the problem, you had to sort a huge list of numbers with this comparison to find out the place of two particular numbers, and it was the solution of the problem. So as the process to compute was really, really costly, it was not possible for me to sort. And I had there is no built-in function of sorting in Cypher with a lambda function of comparison. So I had to be smart, and I did this. So I did not sort the data. I only compared both values to distinguish to everything else to spot their position in the sorted array. But I didn't sort the array, but I can compute the place of those would have if I had sorted it. So it was my solution.
Cool.
This one was fun too. You had like a 2D grid, and some sun was falling, and you had to modelize the physics of sound regoliths of sound falling. There is a lot of nice visualization of it. You can find on Twitter, on it's day 14. And I built like this tree of sound grains, and it was the first part was you had some stones, and the sound was falling on stones, and you had to spot the first one that was falling on the below the last stone. So it was you build it, and it was at the end of it, when some was lower than a threshold, it was over. So it was not. It was complicated to make it work. But when you had it, it was not a lot of big of a computation. But the second part was there wasn't there was some base, infinite base at the very bottom of your stones, and you had to find how many grains of sand to fill all your space, and it was a huge one. A huge grid, and it was not possible for me to compute this with the physics of grains of sand. So I had I did some smart stuff, and I only I compute the connected component of my root. Root, it was like the powering source of the sand, and my connected component with the fall relation, and the size of this component was my answer. So I hadn't to compute all the sand by sand the building of this structure. So GDS helped a lot in this one.
Yeah, sounds a bit more complicated than that. I guess it's always. I mean, maybe a short detour here. It was how difficult was it for you? I mean, how did you find it? I mean, when you think about these challenges, is it complicated to come up with a solution, or did you have to think a lot about, or how do you model this? How do you think about the challenge, or was it oftentimes, oh yeah, I know the way, I know probably what to do here, and then you find your way, or was it lots of think around the challenge a little bit?
I'd say graph modeling is like, it's my way of thinking. It's my mother tongue. So for me, when I have a problem, I graph model this problem. It's the way I work. I've always done that. When I have a problem, I draw it at a graph. So I have a graphy mindset. So for me, it's natural to do that. But these are some very hard problems, and some of them need hours to solve, and I don't sleep a lot in December.
Yes. Okay. Good.
So this one was hard. So I tried to brute force compute it, and I broke my database on my library a lot, because when you it was like a million of billion nodes created, and it's not possible. And every step of computation was a long one, because the way I do it with APOC periodic commit is efficient. It's nice. It's possible to compute, but it may be quite slow, because you have a lot of transactions, and you write your data to disk a lot, and when you do that, you're not as efficient. And by the way, the day after, I had some similar problem with computation and in an APOC periodic, and I had to turn it into a procedure that wasn't writing too much in memory. So it's the way it looked like, with it's quite complicating. I had sensor and beacons. So how can I say that? You have around a sensor. You can on a two-dimensional grid, you have like a disk in Manhattan distance. There is no beacon in the disk, and you have a big set of disks, like exclusion zone in a space, and you have to spot some uncovered spots in your grid. So you have a grid, disks, and you have to spot this isn't this spot isn't this cell isn't in a disk. A disk is like a square like this, because it's Manhattan distance. It's not it's not the round disk. It's a square disk, like a rhombus, but a square with 45 degrees rotation. So this was complicated because the grid was 4 million times 4 million. So it was a huge grid. So I had smart. I couldn't brute force it. I had to make very. I knew there was only one cell uncovered, so I found that it has to be very on the border, very close to the border of some rhombus or anyone. So I only iterate around the rhombus, those dots, and I test if it was inside some. So brute force was not the way, and I had to be smart. And yes, whiteboard helps a lot. The day 16 was like a Neo4j comfort zone. It was a graph problem, pathfinding on a graph, but not that easy, because the weight of a relationship on the graph was a function of the position of the relationship in the path. So you had to do some very complicating reduce function on your path to compute the length of the path. So at the end of it, you had to brute force and to iterate on almost all possible paths, but not with a refactoring of the graph. You can. I built a complete graph. This one you can see on the screen. in which you didn't have to go back to a node you have already visited. So I could use APOC path expand to stream all the possible non-node repeating path and compute the distance of it. But it was complicated. But the refactoring of the graph with Cypher and APOC is like very straightforward, and it's very yes, it goes very smoothly with Cypher, and it's a pleasure.
Did you see other people struggle with this? Because I mean, it was already complicated for you in Cypher, if I understood correctly.
Yes.
And I must be, and that by being a graphy problem, it probably was an advantage to use Cypher. But if other people used other languages that were not as graphy by default, did they struggle a lot with this one?
Yes. Yeah, a lot of problem for a lot of people, because the search space is huge. It's like the number of non-repeating paths in six, like it's 17 node graph is like it's 2 and 13 zeros. So
okay.
So yes, it was hard. You had to. I told it like short, but you have to do some very, very complicated optimization, and this is not all on the language you use. At the end of the day, it's not the main problem. It's not the main part of this problem. You have to be very, yeah. So Cypher is the perfect language to do that, but it's still a hard problem with Cypher or with anything.
Yeah. Okay.
The day the 70s was like a Tetris. You had some shapes folding.
Yeah. Okay.
Yeah, with wind from the right or from the left, so they are moving. They are not rotating, but you have to compute the height of the tower you are building, and it's only implementing the physics of it with APOC periodic. It's easy, and you have to find out the height of the tower after 2022 shapes. So for me, it was computing in like 10 minutes, because I was writing a lot. But the second question was the same one, but not for 2022, but for 1,000 billion of shapes.
Okay.
So I had to wait for some centuries for my answer, and it's still running. No, you have to find some cycle in your events and to find the answer. So if you find the length of a cycle, you can compute the less of a tower and find out the answer.
Yeah.
And yesterday problem was fun. You had a 3D grid graph with some cubes, and you had to compute the area, the exterior area of the shape built with these cubes.
Okay.
So the first approximation is to when you have two cubes next one to another. So you have 2 units of area that you have to remove from the sum of the area of the cubes, that is 6. So 2 cubes like this is like 6 plus 6 minus 2. Because so the first one was you have the cubes, you find the neighbors and you remove. So I built a graph of neighbors. But the second part is like, it's not an approximation anymore. If you have a cube trapped between 6 cubes like this, it's not exposed to the exterior, so you have to remove its value. So I say I'm talking about an empty cube between 6 cubes. Yes.
Okay,
like
a
bubble of air.
Yeah.
Trapped in cubes. So I had to build a graph of air around my cubes and to compute the connected components of the air.
Yeah.
And
Okay.
the exterior connected component was not to consider, but all other connected components, I convert this air into normal cubes. They are lava cubes. So I built a new graph of cubes, and it was then the same problem I had on part one, so I could reuse my part one code with my new shape with bubbles filled of lava.
Okay. Wow. Yeah. It's yeah, that sounds very complicated.
Yes, but it was very fun to do that with GDS. It was reducing the problem. The very hard part of the problem was just these lines of code, projecting a graph into memory and write the connected component in with a black box. I don't want to know how he computes the connected component, if he does a Dijkstra or anything. I have like a free meal connected component, and I used that. So it was nice. And it was yesterday's problem. Today problem. I haven't solved it for now, but it looks very complicated. So
I guess it's getting more difficult every day, and the last one you explained is like I don't know. Sounds very very tough already. So I guess the final, what was it today? 19th, the final 6 will be even harder. So
yes. There are a lot of people sharing visualization of the problem. It helps a lot.
Oh yes, I can imagine.
To find out what's in it, and there are very, very, very nice stuff. Some 3D animations, so very, very cool stuff. There is an emulation around Advent of Code that's very, very nice.
Okay. Yeah, it's a cool community then, I guess, and it's like, what you just described, the challenge from yesterday is like, it's written as a text problem, so you have to read the text, you have to understand what it says, and then you have to visualize what it is, and then if somebody helps you out and say, okay, yeah, this is how it looks like you just described, but with pictures, because there are no pictures here, so it's
there are always some ASCII. Well, no, in this one that's true. There was no
it's like, well, okay, I have no idea what's going on here.
You have your voxels and help yourself.
Help yourself, exactly. Almost need a 3D engine to put it in, and then you have you understand what it is. But maybe that's
But many times it's like test driven. So this is the Tetris. You have the shapes of your Tetris, and you have the direction of the wind. That's your entry.
I see. Okay.
And then you can see the first one. What happens? It's go down, 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 down on the left because of the wind, etc. And so you have some values. You are not alone. There are some.
No, yeah.
The guy that built that is Eric Russell. It's a lot. It's an impressive work.
Is it just the one guy,
yes.
or is it a team?
Just one guy.
Wow, that isn't.
He has some help of testers, but he does it by himself, and he doesn't want you to help him because he wants it to be his problem, and don't want to be accused of cheating or anything, or
Okay.
plagiar. So only he does this. He doesn't want help, and there is never a bug. It works perfect, and it's test driven. Everybody has a different data, so he has coded a lot to generate some relevant data for everyone in a randomized way. It's very cool, and always test driven. If you want to do that, writing tests is a very, very cool way.
Yeah, very cool. I guess you'll continue the advent of code this year, and to try at least to solve the other questions, challenges until the end. So if you are, you try. Okay, cool. So if you are, if you want to follow Pierre on his last week, I guess, to follow the challenges, go to Twitter. And follow him there, or check the GitHub repository. I don't think we have. I haven't linked the GitHub repository.
Yes,
so
but quickly in every tweet you have it.
Yeah.
Yes.
Let me quickly find that. Anyways, here it is. GitHub. Okay, perfect. So I'll share this in chat as well. I'll also post it on the video description in the YouTube video. So if you're wondering how to do Advent of Code 2022 with Cypher, you can check it out there. If you are doing it with Cypher, let us know. Let Pierre know. I guess that would be interesting to see. And maybe you had different ways of solving it, or maybe you had struggled with some similar questions and challenges. And it would be nice to hear from you. If you're doing Advent of Code with some other language, also let us know. That would be interesting as well. And
some comment on the code is supposed to work on both test and input data. So if you have a test .txt file, it should work on it. So you just have to change this param, and you can run it on your test if you want to test the code.
Okay. Yeah. Cool. Yeah, I think with that we are at the end of the show today. This, like I said in the beginning, this is the last live stream we are doing this year. We will. So if you see us pop up live again between the Christmas and the New Year, so basically from next Monday on 26th until the 3rd of January, we stream Best of Nodes on 7 days. Best of Nodes live streams. Well, recordings, Best of Nodes 2022 recordings and reruns. So if you are, maybe you have to work, maybe you have some free time, maybe you want to see a couple of best shows and you don't want to scroll around YouTube to find them, you just can tune in again to these sessions. They will be recorded, so that means most likely I won't be there as a host, but they run and will be interesting, hopefully, for you to watch them. Other than that, we'll be back on the 5th of January with GraphQL Chapter 5, the GraphQL Book Club, and then from then on, continuing in mid-January with more live streams. So yeah, I hope you have had a great day. You had a great time with us. Thank you very much for joining all the live streams. Thank you for being a part. Hopefully this is interesting and as entertaining for you as it is for us. So wishing you a great end of the year. Have a happy new year, and hopefully we see you in 2023. Particularly, thank you very much, Pierre, for being the other day, for doing Advent of Code in Cypher with us, and for showing us the all the challenges and all the all the fun ways to do it with a maybe unexpected way, challenging solving with Cypher.
Yeah, thank you, Alex. Thank you, everyone, and happy New Year, and celebrate with your families.
Yeah, exactly. Thank you, John. Thank you for being here as well today. Thank you, Alexandre. Thank you. And yeah, I guess I'll see you around. Stay here if you want to know more. Follow us on Twitch or YouTube for notifications. And yeah, see you soon. Thank you. Bye.
See you.
Take care,
Goodbye.
everybody.